In July 2015, NASA's New Horizons probe flew by Pluto for the first and only time in history.
Thanks to that flyby, we learned a great deal about the dwarf planet, which became clear and defined both scientifically and in the collective imagination. But the journey of New Horizons didn't end there. On New Year's Day 2019, the probe flew by another planetary body, a small trans-Neptunian object named 486,958 Arrokoth. Arrokoth is the most distant body we've ever visited with a space probe. At first glance, it might seem uninteresting, but it actually hides many surprises and mysteries that we have unveiled thanks to New Horizons. So join us in today's video, as there is so much to say about this small planetary body on the edge of the solar system. In 2006, when the New Horizons probe was launched, Pluto was still considered the 9th planet of the solar system. At that time, we knew very few trans-Neptunian objects compared to how many we know today. These are objects located beyond Neptune's orbit, including bodies in the Kuiper belt, those in the scattered disk, and even comets from the Oort cloud. They are mostly small, cold, and distant bodies, and it's no wonder we struggle to discover and study them. A mission to a trans-Neptunian object would therefore have been very valuable, as it would allow us to encounter planetary bodies never seen before and different from any objects found near the Sun.
New Horizons' objective was Pluto, which it would reach in July 2015, but after that encounter, it would be possible to think about other encounters with similar bodies. The problem was that we didn't know of any within the probe's reach that it could reach without exhausting its operational life. However, researchers knew well that there would not be a second chance for a direct mission to the trans-Neptunian region. So they committed to finding at least one to reach after the Pluto flyby.
Another difficulty arose. For the probe to reach it in time, the body would have to be located within the Sagittarius constellation, right in the region where the galactic center is, making the Milky Way denser. This meant looking for a small bright dot moving against a background of billions and billions of stars. Moreover, if it hadn't been seen yet, it meant it was a small body, less than 50 kilometers in diameter. The search began in 2004, but it took years to accomplish that feat. The techniques for searching for these objects were based on the same procedure Clyde Tombaugh used to discover Pluto in 1930, finding a moving point of light against the background stars at the right speed to be at the required distance for New Horizons to reach it in time. However, in the 2000s, this operation was done with the aid of computer technologies and not just by the naked eye. Several observatories were used, such as the Magellan Telescope at Las Campanas Observatory in Chile, and even the Hubble Space Telescope. Various star catalogs, such as those from the Gaia satellite, were also used to find out-of-place points of light. This way, a team led by astronomer Mark Buoy discovered 5 Kuiper belt objects that New Horizons could potentially reach. The best candidate among these 5 was called 1110113Y. In 2015, the Minor Planet Center designated it 2014 MU69, its provisional name before receiving an official number and eventually a proper name. The number came in 2017 and was 486,958. The following year, the name arrived, chosen by the mission team after receiving suggestions from the public. This name was Ultima Thule, a legendary island in some ancient Greek stories.
Thule was used to indicate a distant and mysterious place at the world's edge, perfect for such a faraway celestial body.
But Thule was also a myth appropriated by Nazi Germany. A few months later, the name was changed to Arrokoth, sky, in the language of the Powhatan Native Americans. The New Horizons engines were then fired up again, and the probe's trajectory was adjusted to reach 486,958 Arrokoth. From the Sun, Arrokoth is the most distant planetary body we've ever visited with a space probe. It is also an object belonging to the class of Cubewanos, Kuiper belt bodies with more or less circular orbits not controlled by Neptune's gravity, unlike Pluto and other similar bodies, the so-called Plutinos.
New Horizons first spotted it in August 2018 from a distance of 172 million kilometers.
After nearly 4 years in the void of space, on January 1, 2019, New Horizons finally flew by Arrokoth. It approached to a distance of 3,538 kilometers while Arrokoth was at such distances. The data sent slowly by the probe took years to arrive, with some moments of New Horizons hibernation to save energy. The last data arrived only in the spring of 2023. At first glance, Arrokoth appeared as a rather curious body.
Even from Earth, we had understood that it was a two-lobed body connected by a narrow neck. We had done this through stellar occultation,
seeing it pass in front of a distant star and studying how it altered the star's light. It is not uncommon to find two-lobed bodies. The Rosetta mission's comet was one, as was the Itokawa asteroid seen by the Hayabusa probe and many other minor bodies.
Only with New Horizons flyby could we better see Arrokoth's two lobes.
At first glance, Alan Stern, the mission director, described it as a snowman, while we compared it to a Caciocavallo or a Scamorza. The larger lobe was named Venue, almost 22 kilometers long in its longest direction, while the smaller one was named Vio, about 15 kilometers in that direction. Venue's volume is almost twice that of Vio because Venue is rounder but flattened in one direction, while Vio is more spheroidal. If all its material were enclosed in a sphere, Arrokoth would be 18 kilometers. The flattening of the larger lobe is an unusual feature of Arrokoth and is a puzzle for astronomers studying planetary formation. How did it flatten so much? In 2020, a joint study by the Max Planck Institute and the Chinese Academy of Sciences hypothesized that Arrokoth's strange shape is the result of millions of years of degassing. Initially, the two lobes were much more spheroidal, but then they slowly lost material, flattening out. Arrokoth rotates around an axis that crosses Venue near the neck region, perpendicular to the axis connecting the two lobes.
It takes about 16 hours for a complete rotation.
It is no coincidence that the rotation is perpendicular.
Researchers believe Arrokoth is what is called a contact binary.
Once, the two lobes were separate bodies that slowly collided in very remote times. Initially, they would have orbited each other, locked by tidal forces to show each other the same face. Then they would have gently merged at low speed, producing the two-lobed body we observe today. The information about Arrokoth's shape and rotation came mainly through photographs taken with New Horizons' LORRI camera. LORRI obtained images starting 2 days before the encounter and up to 9 minutes after, when it obtained its last images of Arrokoth. LORRI allowed us to demonstrate that there are no satellites or planetary rings around Arrokoth, unlike larger objects like Pluto, which has 5 satellites, or Haumea, which has rings.
Researchers used the LASA spectrometer to study Arrokoth's composition.
Like all bodies at such icy distances from the Sun, Arrokoth is rich in ice.
We expect it to have a composition and density similar to comets.
However, the ice is not water but methanol. This can form through chemical interaction between methane and water, but New Horizons found no water or methane. Arrokoth's surface is very red, like many other Kuiper belt bodies, including Pluto. Complex organic molecules called tholins are responsible for this color.
Tholins is a generic term coined by Carl Sagan to name organic compounds formed when cosmic rays hit carbon-based compounds like CO2 or methane.
Along the neck connecting the two lobes is a bright line called the bright collar. We don't know why it is brighter. Perhaps it consists of more reflective ice particles that fell from the lobes over time. This would make it different because, in general, Arrokoth's surface is very ancient and barely shaped by time. There are few craters on Arrokoth, whose surface appears mostly smooth. In some places, there are small depressions, but only some of these are actual impact craters.
On Vio, the smaller lobe, there is a large depression called Maryland, which could be an impact crater. This crater is 6 to 7 kilometers wide and less than 1 kilometer deep.
Anyway, even though these craters are few, they are what one would expect from a Kuiper belt body formed together with the solar system over 4.5 billion years ago. That region of the solar system was relatively quiet regarding micrometeorite impacts, and that's why Arrokoth remained unscathed for so long. Therefore, Arrokoth is the most distant body we have visited, but it is also one of the oldest, remaining almost unaltered since the solar system's origin. Studying bodies like Arrokoth at the icy edges of our planetary system gives us access to ancient information. This way, we can add more pieces to our knowledge of the planetary system, which led us to be here today to admire its beauty and complexity. Thank you for following us this far. We invite you to subscribe to the channel, activate the bell if you haven't already, and we'll see you in the next video.